Good morning, friends. Today we will discuss Thevenin's theorem. Take the definition for that. A linear bilateral network with open terminals AB can be replaced with a single voltage source VTH in series with terminal resistance RTH. Okay. And what about this VTH and RTH? Now we will observe these things. Suppose we have a network linear bilateral complex network. Yes, say these are the open terminals AB, and this can be replaced with the VTH in series with RTH. These are AB terminals. Okay, then where VTH is open circuit voltage measured between AB terminals. VTH is the open circuit voltage measured across AB terminals. Okay, then RTH is resistance measured at AB terminals when all independent sources are replaced with their internal resistances. Their internal resistances are impedances. Okay. Now, for suppose this is a network and these are the terminals A and B. Okay. If we connect any voltmeter here and measure the voltage, that is equal to VTH, and the same resistance, for the same network, if we measure the equivalent resistance between AB terminals, that is RTH. But before measuring RTH, we have to replace all the sources, all independent sources with internal resistances. Okay, internal resistances. But the internal resistance of Vs is, that means voltage source is Rs equal to 0, and that is short circuit. For Is, Rs is infinity, that means open circuit. So voltage source is replaced with the short circuit and current source is replaced with the open circuit when calculating RTH. Okay, now we are going into the problems. Okay, problems based on Thevenin's theorem. Basically we have three types of problems here. Problem type 1. Type 1, network with only independent sources. Network with only independent sources. In this we will calculate VTH and RTH. Okay, and then type 2, network with only dependent sources. Okay, dependent sources means there is no independent source, that's why there won't be VTH. So for this VTH equal to 0, it is default, and we have to calculate RTH by applying a test charge. So that is V test by 1 amp. Later we will discuss in detail about this. Okay, next type 3. Type 3 problem. Network with or having both independent and dependent source. Here we will calculate VTH and also RTH, but RTH is VTH by ISC. Later we will discuss in detail about this thing. Okay, here ISC is short circuited current of AB terminals. VTH is open circuited voltage. Okay, that's it. Now type 1, network with only independent source. Okay, question number 1, find Thevenin's equivalent network. The network is this is 5 volts, 2 ohms, 3 ohms, 4 ohms. These are the AB terminals. Here the network is having only independent source 5 volts. So this belongs to type 1. Okay, so in type 1 we will calculate VTH and RTH, right? So first we will calculate VTH. VTH is voltage measured between VAB, open terminals voltage, VAB. Okay, VAB is open here, so the current will flow up to here, and this is open, so the current will flow here only. The 4 ohms voltage, the current to 4 ohms voltage is 0 because here it is open circuit. So current will flow 2 ohms and 3 ohms only. So the voltage across AB is nothing but the voltage across 3 ohms. Okay, voltage across 3 ohms is, as per the voltage division formula, 5 into 3 by 3 plus 2. Okay, that equal to 3 volts. Okay, how is this formula? Formula is, suppose we have something like this V R1 and R2 here. So the voltage across VR2 equal to V into R2 by R1 plus R2. This is voltage division formula. So based on this one only I wrote this one. Okay, this is 5 into 3 by 3 plus 2, that is 3 volts. Next, RTH. Our network is this is 5 volts, 2 ohms, 4 ohms, 3 ohms. This is A, B, and R equivalent is this one. Okay, but before calculating R equivalent, we have to replace the independent sources with their internal resistance. So the internal resistance of the 5 volt source is voltage source, that's why it is short circuit. So our network will become like this, short circuit. This is A, this is B. We have to calculate R equivalent between these terminals, 4 ohms, 2 ohms, 3 ohms. And here if you observe, this 2 ohms and 3 ohms are 2 ohms, 3 ohms. These are parallel and in series with the 4. Clear? So the equivalent equal to this 4 ohms in series with the parallel combination of 2 and 3. So parallel combination equivalent resistance is 2 into 3 by 2 plus 3, and that equal to 4 plus 6 by 5, that equal to 26 by 5, and that equal to 5.2 ohms RTH. So now the equivalent resistance, the final one R, we know that VTH equal to 3 volts and RTH equal to 5.2 ohms. So now this network, given network, can be replaced with the, this is 5 volts, 3 ohms, 2 ohms, 4 ohms. A, B. This can be equivalently replaced with the Thevenin's resistance VTH in series with RTH. What are those things now? VTH is 3 volts. This is 5.2 ohms. This is the answer. Yeah, equivalent network.